Hello students, welcome to our YouTube channel Experience Tutor. Today we'll go through Web Theory of Light Part 2. Today's topic is interference. This tutorial is meant for any student who is in class 12th, IIT JEE, NEET, EAMS or ready to give any engineering or medical entrance examination. Let us begin. So introduction. We know optics has two parts. One is geometrical optics, where we study about the lens, mirror, and optical instrument, human eye, etc. And transformation of light through different mediums. And the other part is physical optics. In physical optics, we consider that what happens when a light wave travel or propagate around obstacles or through aperture that are not large compared to the wavelength. So what will happen in this situation? We encounter interference and diffraction. Interference refers to a situation where waves from a small number of sources travel different paths and arrive at an observer with different phases. We'll get more clear picture in coming slides when I will explain what is interference in details. Now diffraction. Diffraction is the spreading of waves after they travel around obstacles or through aperture. So this is the main difference between interference and diffraction. Huygens construction, I have already explained it in the previous video. Those who have not gone through it, please go through the wave theory of light part 1. So according to Huygens construction, every point on the wavefront is a source of wavelets. The superposition of light from all these points sources must account from the phase difference due to the different path traveled. Thus, instead of small number of sources in diffraction, we have superposition of wave that are coming from an infinite number of sources. So let us say now after going through the interference and diffraction, we have to know what are the different type of sources. So this is in this slide, just we are going through the definition. I will explain it more details in the coming slide. So what is coherent sources? So basically there are two types of sources. One is coherent sources and other is incoherent sources. So what is coherent sources? Two sources are said to be coherent if they emit light wave on the same frequency and start with same phase or have coherent constant phase difference. They are obtained from a single source. Note, laser is a source of monochromatic light wave of high degree of coherence. Incoherent sources. Two dependent monochromatic sources emit wave of same frequency, but the wave are not in phase, so they are incoherent. This is because atom cannot emit light wave in same phase and these sources are said to be incoherent. By using two independent laser beam, it has been possible to record the interference pattern. Now, this was just the definition. Let us study in detail. So first we'll see what is incoherent sources. Before going through the details of incoherent sources, let us ask a question. Why do we commonly see interference? We, we not commonly see interference effect with visible light, such as sun, an incandescent bulb, or a fluorescent bulb. So let us study in detail. Because light from these sources is at atomic level emitted by the vast number of independent sources. So at an atomic level, this light are emitted by vast number of independent sources. So it is interference cannot be seen by visible light coming from sun or incandescent lamp or fluorescent bulb. So wave from independent sources are incoherent. They do not maintain a fixed phase relationship with each other. We cannot accurately predict the phase, example, whether the wave is at a maximum or at a zero at one point given the phase at another point. So this type of sources are called incoherent sources. Now I hope you are clear about incoherent sources. Now let us see coherent sources. So, okay, one more point is there for incoherent sources. Incoherent wave have rapidly fluctuating phase relationship. The result is an averaging out of interference effect so that the total intensity or power per unit area is just the sum of the intensity of the individual waves. So this is an important point. So total intensity is the sum of the individual waves intensities. Okay. Now coherent sources. The sources are said to be coherent when the waves they emit must maintain constant phase and with respect to each other. The wave have identical wavelength. Only the superposition of coherent wa waves produce interference. Remember, only superposition of coherent waves produce interference. Coherent and incoherent waves are idealized extremes. All real waves fall somewhere between the extremes. The light emitted by laser can be highly coherent. 2 points in the beam can be coherent even if separated by as much as several kilometers. Light from a distant point source, such as a star other than the sun, has some degree of coherence. Now let us see this image. Here, was the Young's technique for illuminating two slit with coherent light. So let me explain you what the image is. So this in this experiment, it is basically Young's technique for illuminating two slit with coherent light. The single slit on the left serves as a source of coherent light. So light is falling as an incoherent light, but the first slit is behaving as a source for the coherent light. Let us move forward. Interference of light. When two light waves of same frequency with constant phase difference impose over each other, then the resultant amplitude or intensity in the region of superimposition is different from the amplitude or intensity of individual waves. The modification of intensity in this region of superposition is called interference. Now let us study about constructive interference and destructive interference. So first, constructive interference: when the resultant intensity is greater than the sum of two individual wavelengths or wave intensities, we represent it as I. I is the common intensity after the interference. After the then I should be greater than I1 plus I2. I1 and I2 are the individual wave intensities of the two waves. Then the interface is said to be constructive. Now next is destructive interference. When the resultant intensity is less than the sum of two individual wave intensities, that is I is less than I1 plus I2, then the interference is said to be destructive interference. Let us study more details about this. So there is no violation of law of conservation of energy in interference. Here the energy from the point of minimum energy is shifted to the point of maximum energy. This sentence is very important. This is a very important point. Sometimes it is asked that whether it violates the law interference, violates the phenomena of interference of light, violates the law of conservation of energy. So answer is no, it doesn't. Now let us see in more detail, try to understand constructive interference. Two coherent wave, green and blue, you can see in the figure, with amplitude 2 ampere and 2 angstrom. This is angstrom wavelength. So and 5 angstrom. Since they are in phase, they interfere constructively. The superposition of the two, that is red shows the superposition of these two waves, has the amplitude of 7. Note that shifting either the wave of the whole of the waves a whole number of cycles to the right or left would not change the superposition of the two. So here what we are getting, two waves with 2 angstrom and 5 angstrom, and the resultant wave, that is superposition wave, which is denoted by red, is 7 angstrom. That is, if we add 2 angstrom and 5 angstrom, we are getting 7 angstrom. So this is an example of constructive interference. I is equal to I1 plus I2, or it can be greater also. Destructive interference. Destructive interference of two waves, green and blue, given in the figure, with amplitudes 2 angstrom and 5 angstrom. The superposition of the two, red, has the amplitude of 3 angstrom. Note that the shifting either of the waves a whole number of cycles to the right or left would not change their superpositions. Shifting one of the wave a half cycle right to the left would change the superposition into constructive interference instead of destructive interference. But here this is the case example of destructive interference. Why? Because if we subtract 5 angstrom minus 2 angstrom, so it is, we are getting the 3 angstrom as a superposition, that is denoted by red. So this is a good example for to explain destructive interference. I is equal to I1 minus I2. Now phase difference, amplitude and intensity in both the cases, constructive interference as well as destructive interference. So for constructive interference of two waves, phase difference delta phi is equal to 2m pi radian, where m can be 0, plus minus 1, plus minus 2. Amplitude is A is equal to A1 plus A2. Intensity is I is equal to I1 plus I2 plus 2 under root I1 into I2. For destructive interference of two waves, phase difference phi is equal to m plus half 2 pi radian, where m can be 0, plus minus 1, plus minus 2. Amplitude A is equal to modulus of A1 minus A2. Intensity I is equal to I1 plus I2 minus 2 under root I1 into I2. So a numerical example for you, just take a screenshot for this. So and try to resolve it on your own. If it can't be done, write a message in the text box of your our YouTube channel where you are watching this video that it was solved by you or not solved by you. If and give your email address, I'll send the solution to you. So this is the whole question. Just take the screenshot or copy this question. If it is not solved, please let me know. I will send you the solution. And don't forget to write your email address. So this is solution is for you. Just you try to do it and let me know the status. So this is end of our today's video. Please subscribe our channel, like and share this video. Thank you very much.